Welcome to Percents Part 3. I ended the last video with going through percent error and describing how to figure out the percent error if you're given how much off the pieces that you were cutting. So that was this first one, 1 inch longer than it was supposed to be. But normally you're actually given a problem like you have in here in example 5, which is a part is specified to have a diameter of 0.250 inches. The actual part measurement is 0.254 inches. What is the percent error? So in order to figure that out, you first have to figure out how far off it is. It doesn't matter if it's smaller or bigger, you just figure out the difference between what it's supposed to be and what it is. So since it's supposed to be 0.250 and it's actually 0.254, you're going to go in your calculator and you're going to take 0.254 and you're going to subtract from it 0.250, and that's going to give you the amount off. Now here it's in scientific notation, and we've talked about this. So 4 times 10 to the negative 3 means that I have a 4, and then I move the decimal point to the left 3 places. So that means it is off by 0.004, 3 places to the left, inches. So to figure out the percent error, I take how far off it is, which is, so percent error is going to be how far off it is, 0.004, and I'm going to divide that by how much it's supposed to be, 0.250, and I want to turn that into a percent. So I want to multiply that by 100. So here, let me do x and 100. So I'm going to do that in my calculator. I'm going to take this 4 times 10 to the negative 3. You don't even have to convert it. You just have to know that's the amount off. And I'm going to divide that by the amount it's supposed to be, 0.250. And then I'm going to take that number and I'm going to multiply it by 100. And I get 8/5. And I want to write that as a percent. And so it's 1.6% is my percent error. So the percent error for this part is 1.6%. And percent error is usually between like 0.1% and 5%. So if you get something like 20%, a really big number, you probably made a mistake, because percent error is usually very small. Okay, so let's move on to tolerance. So this is similar. I want to know the amount you're allowed to be off by. So if I'm allowed to be off by 1.6%, that means that I could be, for this previous example, that means that that's okay, that it's 0.004 inches too large. So the tolerance says what is okay. So for example, you cut a piece of wood 4 feet long, you aren't perfect, so you're allowed to be off by 2 inches. You can make the wood 2 inches too long, so 4 feet 2 inches, or you can make it 2 inches too short, which would be 3 feet 10 inches. Now, when we use the language of tolerance, we use this plus or minus symbol you see here, which means it could be too big by 2 inches or too small by 2 inches. And so you'll see tolerance written in the same units, so inches or feet, or you'll see it written as a percent. So sometimes you have to write it as a number, and sometimes you have to write it as a percent. So here's an example with percent tolerance. I want to write a percent equation with the tolerance as a part, and then I'm going to calculate the percent. So here we are, a resistor. So this is electricity. A resistor is rated at 85 ohms plus or minus 2 ohms. So it could be 87 ohms or it could be 83 ohms. I want to know what the percent tolerance is. So I want to know what 2 out of 85 is as a percent. So what percent is 2 out of 85? That's what this question is really asking. And so let's go ahead and figure out what pieces we know. So I know that part is 2, and I know the whole is 85, and I want to know the percent. So I know that the percent times the whole is equal to the part. percent. So the percent times the whole, 85, is equal to the part. And remember, when we have the question mark multiplying, if I want to know what the question mark is, I divide. So I take 2 divided by 85, and that's going to give me my percent as a decimal. 2 divided by 85 is 0.023529. And so I want to take that and I want to change it to percent. So I need to take that number and I need to multiply it by 100, or I need to move the decimal point 2 places to the right. So if I have that question mark is equal to 0.0235294 as a decimal, and then I make it a percent by moving the decimal point 2 places to the right, I get 2 point, now how much do we want to round it to? Let's round it to the nearest 100th of a percent. So that means 2 decimal places. So 2.35, should it be 35 or 36? Now since the number right after the 5 is 2, I round down, so I leave it. So it's 2.35%. And that is the percent tolerance. And so you can see the percent tolerance written, it would be written as 85 ohms. That little Greek symbol is the word ohms. And then it would be plus or minus, which is a tricky symbol to do. And then it'd be 2.35%. So you can also, you'll see it written as a percent, or you'll see it written as a number with units, and you have to do the appropriate answer. So here's going the other direction. Given a percent tolerance, writing it as a number. An acceptable voltage reading is 15.0 volts with a percent tolerance of 3%. So I want to know, again, I'm going to decipher this into a part and a whole question. So I want to know what is 3% of 15.0? That's what this question is really asking. So that means that the part is what I don't know. The percent, as a decimal, I move the decimal point 2 places to the left. So the percent is 0.03 and the whole is 15. So I know the whole, percent times the whole is equal to the part. Percent times the whole is equal to the part. So I take 0.03 and I multiply that by 15 and I get, as a decimal, 0.45. So 0.45 volts is the tolerance for this voltage reading. So the tolerance is, it's plus or minus again, 0.45 volts. Now, I don't make you write the plus or minus for sure, because that's a hard thing. But you do have to write the units, the word volts. And when you do percent tolerance, you actually have to write percent tolerance in your answer. So make sure you write the words. Okay, let's move on to percent change. So here we are, percent change. Now, this isn't that much different than the percent tolerance. The amount that things are changed in some way. If it went up, it's a percent increase. If it went down, it's a percent decrease. So some keywords for percent change: discount, increased, tip, sales tax. Those are all percent change problems. So here we go with example 8. By replacing high-speed cutters with carbide cutters, a machinist increases production by 35%. Using carbide cutters, that's the new one, 270 pieces per day are produced. How many pieces per day were produced with the steel cutters? So I want to know the old value. So if you look at this, my percent change is 35%, but it's a percent increase. So I went up by 35%. So that means that I have to take my old value, figure out what 35% of it was, add it to that, to the original old value to get my new value. So when I look at percent, when I have an increase, it's not just 35%, it's 100 plus 35% because it's a percent increase, so I add. So when I do this, I know that my percent for this problem is 135%. It's not just the 35%, and that's the trickiest part about this. So the percent is 135%, or as a decimal, again, I move the decimal point 2 places to the right, to the left, so it's 1.35 as a decimal. My old value is what I don't know. That's my whole. My new value is my part, and I do know that it was given to me. It's 270 pieces. So I know that when I take my percent and I multiply that by the whole, or the old value, I will get the new value, 270. So what I'm going to do is, again, whenever the question mark is multiplying a number, to find the question mark, we divide by that number. So I take 270 divided by 1.35. So if I'm given the new value and I want the old value, it's a division problem. If I'm given the part and I want the whole, it's a division problem. So I'm going to take 270 and I divide it by 1.35 to get my original number of parts, 200. So I know that 200 pieces per day were produced with steel cutters. Always take a look at your answer and ask yourself the question, does my answer make sense? If I had gotten 400 pieces per day, it does not make sense because the production went up. It wouldn't have gone up if it went from 400 to 270. So also, if it was something like 20 pieces, I also know that doesn't make sense because there's no way 20 to 270 is a 35% increase. So take a look at your answer and make sure it makes sense. This is just a really good practice in general, anytime you're solving any sort of math-related problem. Okay, example 9. A tool case was purchased for $255. The price was discounted 15% from the list price. What was the list price? Okay, so again, did they give you the new price or the old price? If they gave you the new price, that's the part. That's what you, and if they give you the old price, that's the whole. So since I want to know what the list price was, they gave us the new price. So new value, let me change my color again to red. My new value is 255. My percent, now remember, with these percent change problems, we have to take our percent and either add it or subtract it from 100. So since it was discounted 15%, I'm going to take 100 and I'm going to subtract 15 from it. So 100 minus 15 is equal to 85. So my percent is equal to, I'm going to make that an equal sign. So the percent is equal to 85, or as a decimal, I move the decimal point 2 places to the left, 0.85 as a decimal. So, and now again, I know my new value. I want to know what the old value is, which is, I want to know what the whole is. Okay, so let's write our problem. I know my old value times my percent is going to give me my new value. So that means my question mark is 255 divided by 0.85. Now since it's discounted, my original price should be more than the new price. 300. It is. Great. So the list price, the old value, was equal to $300. Okay? Again, always ask yourself, does this make sense? Okay, example 10. We're getting there. I think I have 12 examples total. So I apologize again for this being so long. Every one is just a little bit different. Example 10. An aluminum bar measures 137.168 millimeters before it's heated. When it's heated, the bar measures 137.195 millimeters. what is the percent increase in the length? Okay, so this one's pretty tricky because we don't know the percent. We know the part and we know the whole. And you can actually go about this a couple of different ways. Since all I care about is the percent increase, if I can figure out how much these two numbers have changed, then that could tell me what I need to know. So I want to know how much of a change I have between these two numbers. So I'm going to subtract them. So 137.195 minus 137.168. And I get 0.027. So the change is equal to 0.027 millimeters, which is abbreviated mm. Now, it's getting bigger, right? So that means it's increasing. This is how much it increases. So this is kind of like a tolerance problem. So I want to know 0.027 is what percent of the original. Which one's the original? 137.168. That's what I want to know. Okay, so the 0.027 is the part, and the 137.168 is the whole. So question mark times the whole is equal to the part, 0.027. So again, to find my question mark, I divide by whatever it's multiplying. So 0.027 divided by 137.168. So let's do that. Divided by 137.168, and I get, as a decimal, scientific notation. Good thing we know how to work with scientific notation. So I'm going to take my decimal point and I move it according to this. I read this right here. It says move it 4 places to the left. So I come over here and 1.968389. So here I am. Here's my decimal point. I need to go 4 places to the left. So I have, I move it to the left of the 1, and then I need 3 zeros in there. So I move it to the point there, and I take it away from there. So, boy, that is tiny. Now this is the percent as a decimal. We have to convert it to a percent. Boy, that's confusing, isn't it? So this is my percent as a decimal. You have to keep track of what you're looking for. Percent is a decimal. So to make it into a percentage, now I need to move the decimal point 2 places to the right. So the percent as an actual percent is 2 places to the right. I end up with just 1 0 before the 1. And then let's round to the nearest hundredth of a percent. So I'm going, since it's a 9 next to the 1, I'll round it up. So 0.02%. That is the percent increase in length. Tiny, 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 tiny. Okay, commission. So there's a few ways to do commission, and one of the ways is to write a proportion. So here you can see I write down what the proportion is. Now it's important to remember that total pay is the commission plus the base pay. So it's very common for car dealers to work on commission. So if you make 2.5% commission, that you have a weekly pay that you get paid no matter what, and then however much you sell, you get a percent of what you sell. So it's very, again, as car sales people, this is a very common way they make money. So example 11, a salesperson earns $250 per week. So that's the base pay, and then the commission is 2.5%. So if a person wants a gross pay, their total pay, to be $900, how much merchandise must be sold? So first of all, we need to state what we know. We know the base pay is $250, and they want a total pay of $900. So how do we figure out the commission? Since total pay is equal to commission plus base pay, I'm going to subtract them. So my commission pay is going to be 900 minus 250. So commission pay is equal to 900 minus 250, $650. Okay, so now I have my commission pay is $650. My percent commission is 2.5%. So now I say, what's the part? What's the whole? So the commission pay is 2.5% of what? So 650 is 2.5% of what? Of the whole. I don't know what the total sales were. I need to figure out how much I have to sell in order to make $650 in commission. So translating, 650 is equals, change the percent to a decimal by moving the decimal point 2 places to the left, and then of is multiply, and I don't know what the question mark is. So again, to figure out the question mark, I take the 650 and I divide it by the percent as a decimal. So 650 divided by 0.025, and I get $26,000. So that means $26,000 in merchandise must be sold. So if you're a used car dealer, you sell one really expensive car or 2 or 3 or 4 small cars, and you could earn $650 in commission. Okay, this is the last example, and it's the most confusing to type into your calculator. Loans. Oops, there's lots of formulas for loans. So if I want to work with a loan, I have to be able to just simply plug a formula into my calculator. Now, these types of loans are very common for auto loans and mortgages, and there's different letters in the formula. So P is the amount you're borrowing, that's called the principal. R is the interest rate, again always writing it as a decimal. N is the number of years, and M is your monthly payment. So this is these letters, you have to read the problem and then write down all the letters and what the numbers you're given, and you'll always have one of the letters is your question mark. So if I want to calculate monthly payments, I have a formula here for M. This is my monthly payment formula. If I want to calculate the number of years and I know my monthly payments, then that's N. If I want to calculate how much money I have to borrow, then that's the P. So I'm only doing one example with one of these formulas because it's fairly complicated to type in. So I'm going to borrow $12,000. So how much I'm borrowing is P. So P is $12,000. The percentage rate is R, and that's 2.3%, and we always write it as a decimal. And then the time that I want to do is 4 years. So I know P, I know R, and I know N, but I don't know M. So let me copy these, and I'm going to put them right next to this formula, because this is the one we're going to use. I know P, I know R, I know M. I want to know M. So if you don't have a calculator like this Casio, you want to start on the very bottom in the inside parentheses and calculate this number, and then raise it to this power, and then calculate this fraction. You want to work in pieces from the inside out, but we have this calculator. We're going to make it look just like this. So we're going to make a big fraction, and we're going to do P times R on the top, 12,000 times 0.023. Then we're going to move down to the bottom, and we're going to write 12. Then we're going to open parentheses, 1 minus, and then I need another fraction. So I just hit the fraction bar again, 1 on the top, and then the denominator has a parentheses, and I write 1 plus, my r is 0.023. Oh, but that's supposed to be divided by 12, so I need another fraction. It's already getting a little bit too big for my screen, but it's still typing it all in there. 0.023, and then that has to be over 12, and then I move my arrow, I close the parentheses, and then I need to raise that, so I use the box, to 12 times n, which is 4, and then I have to close the parentheses on this 1 minus. There. Now you can't even see the whole thing on the screen, but it matches. And I hit equals. And then I say, does this make sense? Would I pay $261.91, well, rounding up 92 cents per month for a loan that is $12,000 over 4 years? And my gut feel is yes, that sounds about right. So rounding to the nearest penny, 261.92 is the monthly payment. This calculator makes it much easier than doing it without this. Again, if you don't have a calculator like this, you just type in the first fraction on the very inside and the bottom, and then add the 1, and then raise it to the power, and you just build your way up and out of the parentheses. That is the end. That's the end. So good luck with all of the problems. If you have any questions, I didn't actually cover every single type of problem, believe it or not. So if you have any issues whatsoever, please, the textbook has a few more examples that I didn't do, or you can contact me, call me, anything you want. Get in touch with me, and I will help you. Good luck.